ClickHouse should survive the pressure of this trench, but I'm not sure that it used somewhere around.
Dale says space ? On the chat.
I like more before about Bay Area. So yes, ClickHouse is used in Bay Area, but maybe should be used more actively. India, of course, many companies are using ClickHouse in India. One of the most, say, one of the most active usage among many.
All right, Tyler, I see that we are now also on YouTube. How is it looking? Do you think we could get started? Or?
Yeah, we are indeed live on YouTube as well. So for everyone who's joined us, thank you so much. You can see that there's a heroes cast of the ClickHouse team here to share with you what's up with ClickHouse Cloud, an update on what we've been doing, as well as a sneak peek into where we've been going. So whether you're watching on Zoom or you're watching on YouTube, please feel free. Drop your questions, your thoughts in chat. We have some time for live Q&A at the end. We'll address that as we get to it. But until then, Tanya, if you wouldn't mind sharing and kicking us off, that'd be amazing.
Sounds good. Thank you, Tyler. Let me share my screen and let me know if you can see the slides. ClickHouse Cloud Update. Wonderful. Okay, so as promised, a little bit of background on how this call came about. I was chatting with Ricky Zaltzer, who is a longtime ClickHouse user and community member, and was early with us on the ClickHouse journey. In fact, if I go to the next slide, we built ClickHouse Cloud and we had intermediate milestones. Ricky actually wins the prize for being the very first user to join our private preview. I believe on the very first day it opened up, loading data, running queries, and actually breaking something. We were very excited. That was the point of the private preview. And giving us feedback throughout this process. And so when we were chatting a couple of months ago, he said, I love attending the monthly core database release webinars. I get really great information there about everything that you're doing for the core database, but I'd love to have like a cloud lens of what you're doing. So certainly cloud specific features, but also a little bit of behind the scenes view. How are you improving the cloud? What are you doing to innovate in terms of architecture? I'm a technologist. I want to understand not only the new features that are coming, but really what's under the hood. And we thought it was a great idea. We actually published a blog for our community to detail how we built cloud from the beginning, and it goes into a lot of detail, but we haven't really done a lot to talk about what's been happening since GA. And so we thought it would be a good time to do this now. And actually, perhaps we can make this, if not a monthly call, but maybe quarterly or something like that. So Ricky, thank you for the idea. Let's see if this format works for everyone, and we're happy to evolve. Maybe just really quickly on my end. So for those of you that don't know me, my name is Tanya Bragan. I'm head of product at ClickHouse. I joined actually a year and a half ago when we were just starting to build out the cloud. I've been in a data space for a while, before then Elastic, ExtraHop, so companies that focused on analyzing large amounts of data. And here I've been focused primarily on working on a cloud offering, but also work very closely with Alexei, of course, on that overall product direction. And just to kick us off, for those that maybe aren't using ClickHouse Cloud yet, and maybe are joining to learn about it, it is a hosted version of ClickHouse. It has what you would expect from an operator perspective. You have a view into your services, how they're running. And from an analyst perspective, we also have something we call SQL Console, which allows you to work with your data in ClickHouse in a native way. This offering is available in AWS, but also in GCP more recently, and Azure is coming soon. And in terms of architecture, as I was alluding to, we chose a slightly different path than many other real-time analytics vendors. We looked at the landscape and we said, what would happen if we stored the data primarily in object store and scaled compute with that, depending on your workload, Data warehousing vendors have been doing this, but nobody in the real-time space has really done that, at least at the time that we started building our cloud. But we thought that it could work. Of course, it would require pretty heavy engineering to optimize the workloads, but we were up for the challenge. So when Alexei talks about the core part, this is where we'll focus, what we've been doing under the hood to actually make real-time analytics work on top of object store. But this architecture has many advantages, and we've seen our users really enjoy using it for that reason. So just something to keep in mind as we go through the presentation. In terms of packaging, also kind of an interesting story. When we first came out with our cloud offering, we had only the middle offering. These were fairly beefy servers, really kind of focused on medium to large workloads, and they worked great for our private preview users. But when we opened up for beta, additional users joined our platform, and they've said, we have starter projects, we have smaller workloads, we don't need as beefy of an offering as production. And we kind of went back to the drawing board and introduced a slightly more scaled down, kind of less HA offering that we call development. And actually, it's become useful not only for these starter workloads, but also if you have a production offering, but you need staging, often our users use both development kind of for the staging workload and production for their main workload. More recently, we also introduced a dedicated offering. This is really for even more specialized workloads that need even higher level of kind of latency sensitive requirements. And that's where we can do some additional hardware customizations and software optimizations for some of these workloads. Right now, we have a few customers running on it, but I would say the bulk of you are running on production and development, and it suits the needs quite well. As mentioned, we run on AWS and GCP, and we are available both directly and through the marketplaces there. With that introduction, I do want to introduce our speaker lineup to talk about what's new in ClickHouse Cloud. First, Kritika and Zach will cover cloud platform. Riyad will talk about integrations, so the ecosystem of tools you may use with ClickHouse Cloud. Alexei will talk about core, and I'll touch at the end on any roadmap items that maybe we have not covered. Throughout this call, I really invite you to use chat liberally. We do have folks on the chat. If you have ask a question, they can respond. But for anything that we don't cover live, we would love to have a live Q&A with you at the end, and we'll source that from the chats. So with that, I'm going to pass this to Kritika. Kritika, if you could cover the cloud platform.
Absolutely. Thank you, Tanya. Hello, I'm Kritika. I'm part of the product team. I lead the cloud platform initiatives. As Tanya covered, we've been moving at a pretty rapid pace with ClickHouse Cloud, and the release cadence with new features continues in the same trajectory. And in this section, I'll cover some of the feature highlights from the past few months, where the focus has been on aiding developer and operator productivity and improving the security posture with additional capabilities and compliance certifications. With that, next slide, please. First on the list is automation and programmatic access. ClickHouse Cloud now supports programmatic access via APIs. We additionally published a Terraform provider a couple of months back. This is really in service of developers, DevOps teams that want to manage lifecycle operations of ClickHouse Cloud services programmatically. Things like setup, configuration, automation of tasks, all of this is much more easier. This helps with standardizing setup, streamlining deployments, and additionally, if you want to script operations such as scaling, which has been popularly used, this can be done directly through the API or the provider. The reception has been very positive. We're making additions as we speak to support additional operations, such as being able to configure private link, encryption, access metrics, billing, audit log information, with the goal of enabling API access to just about anything and everything that you do on the UI. Next slide, please. Next on this list is secure S3 access. ClickHouse Cloud does support the ability to connect to private S3 buckets and provides different ways to do that. IAM access key and secret is one among other options. But the more secure way of connecting based on feedback was the ability to use this notion of an assumed role, where you create an IAM role in AWS that ClickHouse Cloud can then assume into. This is essentially what this feature allows you to do, is to connect to your private S3 buckets in a secure way, both for ingest, being able to access your private S3 buckets directly. This simplifies ingest, migration, and any other use case where you need to access your private S3 bucket. You can connect to multiple S3 buckets from the same service. The feature at this time requires you to go through support, but in the coming weeks, the plan is to allow self-serve setup within the Cloud UI. Next slide, please. The next big one on this list, which took a few months because of the complexity, is bring your own key or custom managed encryption key. Lots of different names for this feature, but this essentially gives the end user control over configuring data at rest encryption policies. ClickHouse Cloud by default for all services offer end-to-end encryption, and this feature is specifically for customers that want advanced protection and isolation of their data by using their own encryption policy. So this is top of mind for InfoSec teams within companies that deal with PII data, and they pretty much mandate use of this feature. The setup, again, requires support to turn it on for you. And today we offer this feature for AWS KMS, for AWS services. And you can configure permissions for ClickHouse Cloud to use the key for data at rest encryption. In the coming months, we'll be introducing support for GCP services by integrating with Cloud Key Management System. And the plan is to extend support to HashiVault and other vendor-neutral tools. The feature right now is configurable at the service level, but the plan is to support more granular controls such as database, table, column-level encryption, and this is all part of the roadmap, which is also required for compliance certifications such as PCI. Next slide, please. So to close this section, I wanted to also highlight that we were recently certified for ISO 27001. We previously were certified for SOC 2 Type 2. This has been since GA. And this is one of the things that we did early on, where we have a trust center where you can access any of these reports and additional security policies, including data classification policy, pen testing, vulnerability assessments, any other information that your security teams need to assess and approve use of ClickHouse Cloud within your company. As you can see, we've covered a lot of ground these past few months to ensure we offload the operational overhead of having to manage ClickHouse and make it much more easier for you to get started and get your insights faster, quicker. You can see information on this and all the other features in the documentation and the changelog. With that, I'm handing it over to Zach to preview the features we shipped recently and once you'll see land in ClickHouse Cloud shortly.
Hang on, everyone, just a second. Alrighty. Hi, everyone. My name is Zach. I work on the product team at ClickHouse alongside Tanya, Riyadh, and Kritika. And today I want to demonstrate to you guys a couple of cool new features that we have recently released, specifically in the SQL console, and then follow that up with a sneak peek at some upcoming features that are kind of currently under development. So you'll see them here first. So to get started, as we all know, ClickHouse is super powerful, but it still needs you to provide your own data. Getting data in and out of the cloud can sometimes be painful, especially kind of using the CLI if you're not previously familiar with ClickHouse and how table structures work and how table definitions work and which table engines to use and all of that good stuff. So just as like a basic example, let's say I've got a table that's totally empty called access here, and I have some files locally that I want to import into this table. Now in the SQL console, there's this third option beneath tables and queries called imports. If I click this option, it'll redirect me to this splash page, giving me some options for importing data. In this case, I think we want a file upload. And I've got a file named access.json. It's fairly small, but still kind of annoying to import into ClickHouse via CLI. If I click this file, immediately we'll start kind of uploading the file into like a temporary S3 bucket. And while that's going on, we actually, in parallel, run schema inference on a snippet of the file and start to generate like a preview of what the data will look like in a table. In this scenario, we actually already have a table called access, as you can see here. So we'll go ahead and select existing table. And as you can see, we've now selected access here automatically. And we've got a nice mapping of all of the fields in our source file to all of the fields in this existing table called access. If anything doesn't look correct, you can modify which field maps to which destination field, and all of these good things. As you can see, the file is now fully uploaded. If we want, we can even take a look at what exactly will be executed against your ClickHouse service here. And if everything looks okay, we can go ahead and click import. And as you can see, as soon as we start importing it, the kind of import moves to the background. You can leave, go get a cup of tea, go about your day. You don't have to worry about, kind of connection latency, as this is being run in the background directly on the SQL Console API server. And as you can see, the import has now completed. And now we have 1.5 million rows in this table. So this is a fairly small example to start with. But let's say we have a slightly bigger file. Maybe it's not even on my local machine, it's remote. It's already in S3. No problem. We can go ahead and click the file URL button instead and input a URL. Hang on. Still have some additional kind of information there. Cool. And so what we'll automatically do in the background is detect the file type. In this case, this file has name headers and it's CSV, so we automatically select CSV with names. And since we don't have an existing destination table, we'll just go ahead and create a new one. So as you can see, that this is a preview of our data. And what we'll do is we'll go ahead and click, we'll go ahead and look through kind of our definitions here. Everything looks okay so far. And in this case, since it's a new table, we also need to define a sort key. So we've got this handy little sort key selector here. Let's say we want to sort by first postcode 1, maybe address 1, postcode 2, and address 2. Now, maybe let's say I want to rearrange the sort key a little bit because the order of the fields in the sort key does matter. In this case, we can very easily just click and drag, and the sort key should kind of update accordingly. Cool. So now that we've got our sort key kind of all configured and everything, we'll go ahead and click import to ClickHouse. And behind the scenes, ClickHouse again will begin importing this file and running an insert statement. This actually leads us to our next feature that I'm excited to show you guys, which is a visualization of currently running queries in your instance. As you can see, now that this insert is running, this queries icon, and now I've missed it already. It's already fully imported because ClickHouse is so fast. Anyhow, so let's say we want to kind of demo what exactly the running queries feature looks like. We can go ahead and open a new tab. Here's a query, and I'll go ahead and execute this. And as you can see, once it executes, we get this nice little UI that shows the query running. We even get a nice progress bar. You can expand the actual SQL here, and as it completes, you can see that the indicator goes away. There's some other cool features around this. There's some other cool kind of ancillary features around this running queries feature. Let's say, for example, we have a SQL statement like this. If I click run here, as you can see, we now have a running insert. And my access just refreshed. Alrighty, we'll go ahead and run this again. And as we can see, this insert is now running. And if I click kill query, it will get automatically killed and the import will stop before all rows have been inserted. All right, so that's the running queries feature. There's more to come on this. I will share a sneak peek later. The last cool feature I want to show you guys is around parametrized queries and support for parametrized queries specifically in the SQL console. So let's say we have a query like this, and we've got a filter on both the year, kind of min and max year that we want included in our kind of aggregation here. So as is, this is static. You can update these directly in the query itself, or you can introduce query parameters. So let's say, for example, we want to add a parameter for the start of the year. We can do this using ClickHouse specific query parameter syntax. We can open a curly brace, type the name of the parameter we want to introduce, the type, and close it. And immediately, as soon as we close it, the SQL console detects that a variable is present and displays an input box for this variable. We'll go ahead and do the same thing for the end year as well. And let's say we want to now look at 2002 to 2007. If we go ahead and run this now, these new values for these variables are taken into account. And as you can see, they're also actually appended to the URL. So when you open a link to a saved query, the SQL console will automatically detect any values for parameters that exist in the query and automatically populate them. This is super powerful for users that want to share queries within their organization. Say you have a report that you're generating with specific kind of values inputted for parameters. This is super easy now. You can just share the entire link. Other people in your organization with access to the service can click it and immediately get exactly the same parameters that you are running. All right. This query parameter support also extends to parameterized views as well. Let's say we've got a view here called hits by site. This is based off of the hits table you can see here. And it's got two parameter fields. One is a date and one is a minimum number of unique hits. Now, because you need to actually input values for these parameters in order to return any results in this view, and initially it shows up blank. But if we enter some values into these inputs, let's say min uniques is 10,000, we can go ahead and update view. And as you can see, the view has been updated with our kind of parameters attached. All righty. So I think this kind of concludes our kind of exciting new features. I'd like to share with you what is yet to come. All right. So as we kind of demoed earlier, we have this brand new imports feature. One thing that is noticeably missing from it at the time being is monitoring for in-progress imports. Since these are being run in the background and you're not running it through the CLI, at present, you currently can't kind of see the status of, the exact status of the import at any given point in time. We hope to fix this by also kind of including this beautiful file upload progress or URL import progress flyout that gives you the visibility needed into different steps of the import, for example, table creation and insertion, and also gives you the option to cancel the import as well. Secondly, say your import fails. This is always annoying. We will kind of expose to the end user exactly what went wrong during the import, which step failed, what the error message was, give users the option to either retry as is or modify the actual import object and try again from the beginning as well. So hopefully this will serve to kind of reduce pain even further on getting data into ClickHouse Cloud. All right. Secondly, as part of the running queries feature, obviously we show kind of a very brief history of kind of past executed queries. We only show 5 in the current popover that I just demoed to you. The idea being that eventually we'll follow it up with a more holistic view of all of your queries, both running and finished, and allow users to inspect, stop potentially if it's a running query, but inspect different queries by different users, potentially even look at performance of queries over time, basically all kinds of aggregate statistics around running queries, past and present, in order to kind of improve observability inside of ClickHouse Cloud. Third, and this is one that I'm super excited about, and thanks to Ricky for bothering us ceaselessly about implementing this feature. But as those of you who currently use ClickHouse Cloud know, the SQL console has this really nifty feature, which basically enables passwordless authentication on a service. You just click a button and we automatically kind of generate a certificate and authenticate you on the service. At present, this feature is only available for admin roles, but in the near future, we are releasing kind of access control based on role for the SQL console, such that developer roles and any future roles that users might define in the future can be kind of more granularly configured. That way, passwordless authentication can be extended past admin roles to basically any user in ClickHouse Cloud. All right, moving on. So one cool feature in the SQL console is the ability to save queries. As I mentioned in the parameterized query section earlier, we kind of hope that users are able to kind of find some joy in being able to very quickly kind of prototype and share queries around with other members of their organization. One thing that this feature doesn't currently take into account is the difference between saved and private queries. All saved queries currently in the SQL console are shared with all users that have access to a service in the SQL console. As I just mentioned around extending SQL console access to other roles, though, maybe you just want to have queries that are personal, and maybe you want to have queries that are just shared with other admins or other developers or a subset of one of those. This will soon be possible in the SQL console. We'll kind of introduce this more granular kind of access control, which allows you to kind of determine who has access and what level of access to a specific saved query. As you can see kind of from that previous shared query modal, we also plan to introduce something called query API endpoints. This is another feature I'm super excited about. Basically, we'll expose a REST API for all saved queries. So instead of having to kind of instrument a driver in your application in order to consume query results, you can simply generate an API key within ClickHouse Cloud, create an endpoint for a saved query, and then point your application towards that endpoint and start consuming query results immediately. This is super, super exciting because basically it means that, for those of you that are DBAs, you don't necessarily have to keep working every single day with members of your team focused on front end. You can set up a saved query for them once, show them how to modify it and save it, and just generate an API key. All of a sudden, they'll be able to very quickly start consuming results. This should reduce the number of steps it takes for users to get into ClickHouse Cloud, get their data in, and immediately begin using ClickHouse to query their data and return results in their application. Very kind of relatedly, we're also going to kind of introduce monitoring for these query API endpoints. So say you have different keys that are hitting this endpoint, you'll be able to kind of monitor requests over time, disable and enable keys, all of that goodness. So yeah, that basically sums up API endpoints. Finally, coming in the very near future, we also are excited to announce an LLM integration directly in the SQL console. Basically, we will take any sort of user-generated prompt, such as the one you see here, and basically run it through an LLM in order to generate a SQL query specific to ClickHouse that satisfies the prompt. Additionally, say you have a query that's erroring out, there will also be a button that allows you to fix my query and make it better. So these are some of the features that we're super excited to bring to the SQL console in the upcoming weeks. We hope to hear your feedback as they are rolled out. With that, I'll hand things over to Riyadh. Thank you all.
Thank you, Zach. Well, we're transitioning to Riyadh. I just want to remind everyone, if you plan to send messages in chat, just check again if you're sending it to everyone or to host and panelists only. I even noticed folks on our side are sending responses back to users, but actually not sending them to users because you're just sending it to host and panelists. It's Zoom chat is tricky. I would recommend everybody that doesn't mind their responses to be seen by everyone, just switch the chat to everyone. All right, Riyadh, I know Zach is a tough act to follow. Over to you.
Thanks, everyone. Hope everyone can see my screen here. Can you just confirm?
Yes.
All right. Great to be here today. I just lost power for like 5 minutes. You cannot make it up. So like 1 minute before going live, and that's always fun. But okay, I'm Riyadh. I'm from the integrations team, and I'm here today to talk about our efforts in the integration space. Basically everything around what's useful to integrate with ClickHouse, from getting your data in to querying data to interacting with ClickHouse. No one really uses just ClickHouse by itself, maybe except Alexei here in the call, but people try to put it into a broader stack, and that's basically what we deal with in the integrations team. The first feature I'm pretty excited about is a pretty big one. It took months of efforts from a fairly large group of people to get it done, so kudos to the team. And it's called ClickPipes. So ClickPipes is a cloud exclusive experience in ClickHouse that allows you basically to create continuous ingestion jobs from remote data sources. We decided to focus ClickPipes on Kafka to start with because of the sheer amount of demand we got there. And the main characteristics are summarized in our website here. So I'll leave it to you to basically investigate further, but it's that easy to use and it's built for scale and reliability. It's a whole platform underneath, and it does not stop with Kafka. It's a bigger story. We'll get back to that later, but the best way to really display ClickPipes and how it works is just to basically run it and see a demo of it. So result of my power outage, I lost my token, I guess. But let's connect here to the SQL console and see how it works. So preparing this demo, I loaded the data set into the SQL console here of my service. And it's a very familiar data set for people that are into the technology space. It's the Hacker News data, where basically you have data on comments and posts from Hacker News. And this is an interesting one, but it is a pretty static data set. In fact, it is from the creation of Hacker News until 2021. So it's great for like historical analysis, but Hacker News is a live experience. It's happening every day. It's happening as we speak now. People are sending comments. So it's better if we can like just combine this like historical view with a live view of what's happening. So preparing this, I created a topic on Confluent Cloud that's basically reading an RSS feed and pushing it into this Kafka topic. And this topic basically is showing basically live data flowing from Hacker News. And this one is live. You can see here that it's fairly recent, and these are like the same thing, but this time live. And let's try to ingest this. So we go to the imports view that Zach introduced earlier, and ClickPipes is this ingest from Kafka button. And we support various flavors of Kafka. Confluent Cloud is actually a launch partner for this feature. All the alternative versions under Apache Kafka, so other providers, self-managed versions, and Amazon MSK. Let me pick Confluent Cloud for this example, and let's call it Hacker News Live. Let me put my credentials in there. And this is my broker. We auto-generate a consumer group ID here for you. We support schema registry. But here I'm going to just hit next and select my Hacker News comments topic. We support JSON format for the moment. And the formats we list here are what's coming next. So we'll be pretty focused on Avro as the next format we'll be supporting. And this looks like my Hacker News data. There's someone seeking work in around Dresden in Germany. So that looks good to me. Let me hit next. And in this view, a little bit like the file upload view, you have a choice between picking an existing table, so I can append data to my Hacker News table in this case, you just need to map data from the feed to data into the table, or you can just give it a name and let's call it HN live here. Let's pick a sorting key. So this feed column here looks redundant, so let's just drop it. We pre-populate this date here. Let's put it as a date time, and let me pick a replacing Mercury engine for this one. Oh, the zoom view is okay here. Hitting next, we decide how we want to handle exceptions. So there's a concept in the Kafka world called dead letter queue, where it basically you create another topic to write mal from data to or errors. Here we use a table for that in the destination ClickHouse service that has a TTL of 7 days. So we keep your data around for 7 days. Any errors or mal from data will show up here. Hitting complete the setup, we register this continuous ingestion job for me into the ClickHouse Cloud platform, and we see that it is provisioning. Something to keep in mind is that this is running independently from your ClickHouse services, powered by other type of processes. So it's completely decoupled. And this is a feature of ClickPipes. It means that we can scale it out fairly easily. We can resume from clean state. We can manage these ingestion jobs independently from your database server. And that might be the difference between a Kafka table engine, if you ask yourself this question. So it is provisioning. Data from the source is the data in the remote Kafka broker. So data on Confluent here, data on the destination table is already there. So we ingest the data. And if I click view data, I see that I have 50,000 rows, almost 51,000 rows already ingested from 2023. And as you saw, took me like less than a minute to set up this job. So we have big plans for ClickPipes. You see that we support right now 3 flavors of Kafka. We will be adding to this list pretty aggressively because now we have the foundations for like a scalable continuous ingestion platform. So expect more in that space, especially around streaming ingestion and anything that our users will request. All right, next is a feature also I'm pretty excited about because it expands our compatibility. It has been available in open source. The name of the feature is the MySQL interface, but it was absent from ClickHouse Cloud for a few reasons because its protocol is pretty complex actually. And what we've done is that we decided to create a kind of opt-in experience. Now you can just flip a switch and enable the MySQL interface for your ClickHouse Cloud service. And why you want to do that is just to integrate with tools that have MySQL compatibility, whether it's your own code that you wrote for MySQL and that you want to port easily to ClickHouse Cloud, or maybe it's one like data visualization software or BI tool, mostly, that you are already using that's not provided with the ClickHouse driver. And for this, you can just use this MySQL interface. Since MySQL is a fairly old and established standard out there, we tested it extensively for Looker Studio, and we also made a lot of improvements to ClickHouse itself to improve compatibility with Looker Studio, and it's currently available in private preview. Let's see how it works. Let me show here the connection string of another service. We have native HTTPS as usual, but we have also this enable MySQL interface that is already activated for this service. And now let me open up a terminal, for example, and let's see how it works. So I'm connecting here to my MySQL service. Please remind me to change my password later. So this is a MySQL client, the CLI client connected to a ClickHouse Cloud service. And we can see basically what tables I have here. These are my ClickHouse Cloud tables. We recognize the Hacker News, comments, and all this data. And what you do with a MySQL connection on top of a ClickHouse service, well, basically you do analytics queries. So for example, here, a breakdown of the counts per month for the whole data set, and you see that it's pretty fast. You can do it, for example, also a breakdown per type. And if you're familiar with MySQL on 28 million rows, these are not normal processing times. So this is really specific to ClickHouse. So the MySQL CLI is cool for demonstration purposes, but I think ClickHouse CLI is really superior. A real use case would be to use something like Looker to connect. Unfortunately, Looker is having, I think, problems with their MySQL connectivity. So let's see how another Cloud BI tool can integrate. So let's pick MySQL here from QuickSight. And let me just copy some credentials around. I have my host name here. That's my database server. Oh, cool. It's already saved. That's my port. Default MySQL port. Let's give it. And my saved credentials. And I name it live ClickHouse Cloud. Let's validate the connection. This is QuickSight running from Amazon. It's validated. We can create the data source. And now we can use basically QuickSight, even though it's not provided with ClickHouse connector. Let me pick, see this table here, alt aggregate. And do we want to import it to the local storage? I don't think so, since we're talking directly to ClickHouse, and it's the whole idea. And now we are directly querying from QuickSight to ClickHouse. So let me put here some data and visualize basically the same Hacker News data set, but now this time in QuickSight. So pretty excited about this because a lot of users asked for it, and because everything that expands our compatibility means that users will be happy. We are actively monitoring other tools. So if you have a preferred tool that is not working with this interface for some compatibility reasons, please raise an issue and we'll make sure to tackle it. Finally, a lot is also happening in the integration space all over the year. I removed a lot of the details here because it's a very high cardinality space, but few main updates. We have a Kafka Connect sync, an official one for ClickHouse that is now GA as of now. That's pretty exciting. We just released 1.0 after we made sure that exactly what semantics are valid, and we'll be publishing some content about it very soon. So expect that. You can already run it. You'll find it in the Confluent Hub or on GitHub. We just released our very own Power BI connector. It also has been an interesting effort from a new joiner in the team called Bensi. Just has landed in beta. So if you're using Power BI, you can use this one as well. We are ongoing a huge redesign of our ClickHouse Grafana data source to basically improve the UX and the UI of it for our users. It's one of our most popular it's one of our main basically UIs, and people love using it. But V3 has been released now something like 6 months ago. So we are head down working on a redesign. Our JavaScript client is now browser compatible if you want to run browser-based scenarios. And finally, we keep improving our main language clients from Golang to Python. Every day there's like new improvements around compression, around retries, around network management. So I'll leave it here. And if you have any questions, please use the QA feature. Thank you very much.
Thanks, Riyad. All right, so I'm going to share more slides when you unshare, and next we have Alexei. All right. So the last media section, Alexei, over to you.
Yeah, could you please enable my video because it is disabled?
That's Tyler's.
Ah,
Powers.
no problem.
I've asked to start it. You have to click the yes button.
Okay.
There we are.
So I am Alexei. I hope you know me already. So I will not tell you who I am. So next slide, please. I will instead tell you about what is inside ClickHouse in ClickHouse Cloud. So ClickHouse Cloud uses separation of storage and compute with shared storage in S3 or GCS. It also uses write-through cache with local SSD and RAM. And when you hear about object storage like S3, you might ask, is it fast? maybe you have some impression that object storage is not as fast as local SSDs, and you will be right. But it is not so easy. At one side, everything that you write into ClickHouse in ClickHouse Cloud is immediately written to the shared storage. But also the same data is written to local SSDs and cached in RAM. And this cache is available on every replica. So when you query this data, it will be served from local SSDs. So you might ask questions, is it scalable? Is it fast? And the answer will be yes and yes. But how? Let me show you some numbers. Next slide, please. First, I will show you some numbers that are pretty easy to obtain. To get these numbers, you just create a service in ClickHouse Cloud. You scale it up, you upload your data, and watch how fast it will do on your data. One question, how quickly you can insert 1 trillion records to ClickHouse Cloud? And we have a number from one of the customers. This is a real number on real data set on several trillion of records. And 1 trillion was inserted in slightly more than 1 hour, 1 hour, 10 minutes. Yes, I will optimize it to be slightly less than 1 hour, but currently it is just 250 million records per second. And if you did not use ClickHouse before, you might be impressed with this number, but for me, it is just what to expect. This is on some data set with a time series data. Another question, how quickly you can scan your data in a single select query using all the parallelism available in ClickHouse Cloud? And the answer will be, for example, it can work processing 191 gigabytes per second. Again, if you're not familiar with ClickHouse, you might think this is insane, how it is possible. But for those who already use ClickHouse, this number is what to expect. You expect ClickHouse to be fast, so it is unsurprising. And for me, for ClickHouse developer, I will ask myself, why just 191 gigabytes per second? I want 200. Why not? Why it is slightly less than 200? I still have something to optimize. But anyway, these numbers are easy to get. Let's look at some other numbers. Next, please. Some other numbers are much harder to get and required a lot of work to optimize how ClickHouse actually works with shared storage. And this is the case when you spend a month or two optimizing something like P99 and 9 several nines latency, just a few milliseconds, and everyone will ask you, why did you wasted so much time for just a few milliseconds? But you will say, this is how everything should work, and this is where real work done. So the biggest question is latency, especially the latency for short queries, the latency for a single insert query, peak latency, especially on highest percentiles. Let's take a look first at short queries latency. This depends on where the data is actually located. if it is located on object storage, you have to request it, and if it is not in the cache, you have to request this data from object storage, and it has its own distribution of latencies. It can go up to several hundreds of milliseconds, and you have to do maybe hundreds or even thousands of requests, even for simple queries. And if you look at, say, median latency, you can see that like half a year ago, for a simple query, let me also describe this scenario. So I'm constantly looking in a way how to find where we did not optimize the performance to the maximum. And if you just load your data and query, you will see that it takes about 0 time, say 10 milliseconds, 20 milliseconds, because it is just a perfect scenario. Data is in the cache, you query it, everything is perfect. But what if you will constantly load, say, hundreds of billions of records during a hour using parallel connections, and at the same time run select queries for real-time dashboards? So real-time queries on constantly updated real-time data. And this scenario is way trickier because when you insert data to one replica, it's not clear if it will be in the cache in another replica. And half a year ago, median latency on this type of queries was over 400 milliseconds. Today, it is just 157 milliseconds. And we did it by enabling one interesting feature named cache pre-warning on replicas. Other interesting optimizations, like how long the query will take if your service was idle. So it was turned off, and you turn it on by just connecting to the service. It is turned on automatically, and you do a query. And 1 year ago, a query of this type, like a range query, took 9.9 seconds. Today, it is just 2.3 seconds. And what is interesting is that the baseline that we set up for this query was 5 seconds on ClickHouse server using local SSDs only. But today in the cloud, it is 2.3 seconds. How it is possible? And the answer is we have optimized both ClickHouse Cloud and self-managed stubs with local SSDs. So both scenarios became faster. Maybe on self-managed, it is also 2.3 seconds, maybe even less. If you look at inserts latency, what if you will do 1,000 of small inserts with a single record? And 1 year ago, it was 100 seconds, so just 10 inserts per second. Today, it is 68 seconds. Pretty significant optimization. Maybe you expect it to be like 0 instead of 68, but let's take a look. Next slide, please. So what is interesting for scalability of ClickHouse Cloud? In ClickHouse Cloud, you expect your services to be automatically scalable at runtime. So you run one query, it has 3 replicas, say 8 gigabytes of memory each. 10 minutes later, you run another query, and we automatically detect that there are a lot of queries running concurrently. They need more memory, they need more CPU, and we scaled this cluster up, and now it is prepared for a higher workload. So how it is possible? For this purpose, we implemented a new table engine named Shared Merge Tree. It is used in ClickHouse Cloud by default instead of replicated merge tree. We have enabled it for every new service currently in development tier. And what is the difference between this new table engine and replicated merge tree? This table engine does not require any local metadata. So it provides full separation of storage and compute. When you add a new server, you just add it as empty, fully stateless. It automatically connects to Keeper. The metadata is stored in a centralized way in a ClickHouse Keeper, and it became just a new replica. It improves server startup, and even the complexity of implementation is less than for replicated merge tree, because when you insert data, it is instantly visible on every replica. Replicas cannot diverge, and you can scale up to, say, 100 replicas, 300 replicas. No problems. There are some limitations. This table engine is implemented specifically for the scenario that we have in ClickHouse Cloud. So it is not open source. In open source, you can also use separation of storage and compute with replicated merge tree using multi-region replication or zero-copy replication across multiple availability zones. Next slide, please. And one interesting bonus that we already provide in ClickHouse Cloud and going to provide for every ClickHouse users is lightweight updates. What is it? So before lightweight updates, when you do update query, actually there is no update query, there is only alter table update query. And this query was processing in the background by rewriting the data inside columns. But with lightweight updates, you can enable this setting, apply mutations on the fly, and it will activate multi-stage update process. So it will instantly record the expression for update, and this expression will take effect immediately for every subsequent select query. Then it will be transformed to some sort of patch parts that are also merged on the fly. And only then updates are going to be fully materialized. So it will be implemented for both shared merge tree and replicated merge tree. And today we have already implemented stage 1 for shared merge tree. So it is available to try. Next slide, please. Okay, back to Tanya.
I think that's me now to bring it home. So we recognize that we're at the top of the hour already. We knew we would have too much content because we really haven't done this enough in the past 9 months. So we had a lot to cover. Hopefully, if we do it more regularly, next time we'll have less to present and more to discuss. But let me bring it home with just a roundup of the roadmap for the items that we didn't cover. And of course, this doesn't have everything on our roadmap. So this is just the highlights. And the way I've grouped it is, first of all, security and reliability. And the anecdote I like to tell here is, before we hired even a single cloud engineer, we hired a security architect to work with us to ensure things like compliance and security capabilities were not an afterthought. And this trend continues. So in addition to things that Kritika already covered around ISO 27001 compliance and bring your own key for encrypting data, we're working for additional backup controls and option to bring your own bucket for backups or cross-regional restores. This is important for your disaster recovery. and other initiatives. And then on the authentication side, we're also looking at expanding our single sign-on and SAML coverage. And a few of you asked about this in the Q&A. Yes, we're working on this, and we can cover during the live Q&A a little bit more detail on this initiative. And then the rest of the roadmap I've divided into operator improvements and analyst productivity. On the analyst productivity side, Zach has already covered a lot of really interesting capabilities as part of the SQL console. And just some additional things I'm excited about is expanding our coverage of sample data sets. Most of you already know that we have a playground that is publicly available, but in ClickHouse Cloud, we only expose 3 of the sample data sets. And that's because they're kind of a pain to load. It takes a long time to do it through the browser. What if we just instantly attach them? This is possible in ClickHouse. Over the past year, we've developed this capability. We can just provide you with instant read-only access to these data sets and just make them instantly available. This is pretty exciting, and we're working on this. And then in terms of UDFs, back to the security pillar, we have to do this in a cloud-native way, in a secure way. So we're looking to use sandboxing techniques to expose that in ClickHouse Cloud as well. And then in the middle column on the operator side, again, Kritika's already covered a lot of this, but on the observability side, we have a basic dashboard, and then you can use system tables to query more data about your service. We're looking to expand that to include things like a Prometheus exporter and other types of collectors for third-party observability services. This has been a request, and we hear you, and we are definitely working on this as a theme. And finally, on auto-scaling, I mentioned in the beginning, this is going to continue to be a big area of investment. We have a pretty big milestone coming here in the new year, improving auto-scaling speed and reactivity, as well as additional controls and more automated horizontal scaling. So lots to come here on an auto-scaling side. Finally, in the beginning, I mentioned where we currently are in AWS and GCP. We've been getting a lot of questions around Azure. The interest in Azure, frankly, just skyrocketed since beginning of the year. I wonder why. This is work in progress. We are tentatively targeting a private preview for Azure in Q1 of 2024. We already have a lot of interest in joining us early on this. If you would like to join our waiting list, let us know. We'd love to connect with you and see if it makes sense to add you to that group, but definitely work in progress and one of our top priorities. And finally, there was a question on region availability. This is something that we continue to expand. We started off in primarily North America and Western Europe. We over time expanded to Asia Pacific and are looking for additional global expansion. If you have feedback on additional regions you'd like to see to run your workloads, please let us know. There's a process for this working through our support team. Just raise a support ticket, or right now, just in chat, let us know. And this is something that we can follow up with you on. So that's really it. I'm going to stop sharing the slides, and I invite the panelists to turn on their videos. For folks that can stick around, I see we still have quite a few folks still on the Zoom webinar. Let's cover some questions live. And again, I want to thank all the speakers for preparing content and presenting just now. So let me go over to the doc. Kelly, thank you so much for manning the chat and collecting these questions. So to kick us off, Alexei, I'm going to pick on you first. There was a question, will querying be slower with S3 versus, kind of local storage? And I think you covered it, but just to bring it home, like a 60-second answer. You're with a user in an elevator, you got 60 seconds. Is it slower? Is it not? And just really, how much have we really improved it in the past year?
The short answer is no. I also have a longer answer, and it is sometimes a very specific query can be slower if you compare the same resources with object storage, and the data is not in the cache, so it is a cold data, and you have local SSDs, so not EBS, on a self-managed setup. And in this case, the query could be potentially slower. And one more, if it is a short query bounded by latency. In this case, you might expect several hundreds of milliseconds of latency due to communication with object storage, and less latency the on local SSDs. So particular queries could be potentially slower, but we do the maximum to lower this chance as much as possible.
Thank you. Makes sense to me, but hopefully if folks have more questions, drop them in the chat. All right, so who am I going to pick on next? Kritika, how about you? Quite a few questions on the cloud platform. So first, maybe just around regional availability. Anything to add to my answer around sort of like how we expand and how users can request additional regions?
Yeah, no, use the support to request. So we constantly look at the region requested and prioritize based on demand, because there's this notion of a fixed cost to spin up infrastructure in a region. We always follow the model of if we see demand, we'll spin it up. We have a handful of customers that have looked at the closest region to spin up the service because the latency hasn't been prohibitively high. So if that doesn't work for compliance reasons, if you need the service to be in a particular geo, use the support to raise a request. It comes through to us and we'll communicate if we do or if it's coming soon. So you'll have that answer fairly quickly.
Okay, sounds good. And there was a specific question about US West 1 and GCP. I don't know what exactly that is, like which city that is, but has that come up at all?
Not a whole lot. I mean, with GCP, I do acknowledge we have only 3 regions, one in the US with Iowa, South Central, that came up as more frequently used. But West 1, I want to say it's either California or Oregon. But yeah, we'll look at the list. I mean, in case if you haven't already submitted a request, if you can do that, we'll look at it and let you know if we are able to prioritize that.
Sounds good. Okay, so the next question was, and I'll keep with you, Kritika, for now. Is there a plan to bring your own cloud? I think it's a good question. Obviously, this is something that we've been discussing internally. So maybe a short answer, kind of how we think about it right now and kind of where that is in our journey, because I did not talk about it as far as the expansion.
Right. So one of the things that the early customers who asked this eventually pick the route of the dedicated service, because it does give them the isolation, the latency, performance guarantees that they need. That's one approach to take. If bring your own cloud for compliance reasons is the mandate, please submit a request. As I said, this is a consideration on the roadmap. But yeah, we would definitely like to partner with you to understand your use case and include you in the design discussions.
Yeah, and this is just a little bit about how we build. We really like to build with design partners in mind. And so so far we've had a couple, but then they ended up going the dedicated route. And so that sort of kind of resolved itself. So always looking for more design partners to work with us. Please reach out if you haven't yet, engage on this conversation. And it's something we'd be keenly interested to learn more, kind of how you think about it in your industry, in your use case. Okay, thank you, Kritika. Maybe just to give you a break, I'm going to switch over to Zach for a second. So first of all, Zach, great reactions on SQL as an API. Thank you, Ricky, for your enthusiasm, but I know others were excited as well. There was a question on the parameterized queries, which I didn't quite know if it was applicable, so I figured I'd ask you live. There was a question, can query parameter be used along with ClickHouse JDBC driver? And I'm not really sure if that even makes sense to you. I think that was about the parameterized queries. I think it was asked during your section.
Yeah, so it was probably asked during my section. Just to clarify, the query parameters that we've introduced in the SQL console is just kind of trying to achieve feature parity with the ClickHouse HTTP interface, which is what the SQL console uses to execute your queries. These parameterized queries are kind of actually already natively supported by ClickHouse itself. And I think that the JDBC driver offers both HTTP and native options for for actually connecting and querying a service. In this case, I guess for the HTTP interface, as I understand it, the JDBC driver allows you to append any query parameters directly to the URL string. And then I think that there's kind of a similar implementation for the native protocol as well with the JDBC driver. But on the native protocol, you obviously use a set command in order to set a query parameter. So basically you'd open a connection, set these values, I guess somehow instrumented in your application, and then pass them through as part of the kind of query that you're actually executing against your instance. Hopefully that answered the question. Riyadh actually might know more about exactly kind of how the JDBC driver works, but to clarify, the SQL console is basically just exposing the parametrized query protocol that exists already on the ClickHouse HTTP interface.
Riyadh, anything to add on that one?
No, I think sounds good on the HTTP. I'm pretty sure it will work since it's provided by default in the Java driver. I'll have to look up for parameterized views on the native protocol. I'm not really sure about it, but if it's not the case, we'll make sure to open an issue.
Sounds good. Okay, and Riyadh, just since you're unmuted, next question I'll throw to you. Any plans to support protobuf format for ClickPipes?
Answer is yes. We already had a couple of requests on protobuf. It's one of the formats we are considering. It's not in the short list of the ones that we will try to tackle this year. So this year we are focused on Avro and tabular and columnar formats, just because of the amount of demand we see, and also because of the fact that Avro is the standard format of Confluent Cloud, our launch partner, and we see a lot of traffic coming from there. But yeah, if we see more and more demand for protobuf, we'll make sure to prioritize it. It's I'd say a target for first quarter of next year for us.
Very good. Okay, Alexei, next for you. Are there shared replacing merge tree, shared aggregating merge tree, and so on? There was a question. I'm not quite sure if we covered it in chat. Do you want to comment on that?
Yes, you can apply any modifier for shared merge tree, similarly to replicated merge tree. Moreover, if you create a table with, say, a replacing merge tree engine in the cloud, it will be automatically converted to shared merge tree, replacing shared merge tree actually. So if you run this query, then do show create table, it will show you this magic.
Very good. All right. Kritika, on the SSO SAML side, I don't know if I covered everything you would say on that. Also, there was a question, can we integrate with SAML AD for auth or Google Auth or Keycloak? So anything you want to share, kind of more specifics on this SSO SAML initiative?
You covered most of it on the roadmap slide, but yeah, the plan is to have an SSO integration hopefully later half of this year. Azure AD, Google SSO is already supported. We have a few others, including Okta, that we plan to ensure validation and support as we iterate through additional IDP. But by following the SAML standards, the goal is to have the user bring their own IDP and integrate seamlessly. And just to add, we'll also have additional MFA policies that you can configure. So we're really hardening the stance on sign-on and other advanced capabilities that you'll need there. Sorry, go ahead.
Sounds good. Yeah, cool. And so I think I'm going to, at this point, ask the last question, but if the speakers could look at the doc that Kelly put together, if there's something I didn't pull into the answers that you want to answer, maybe quickly pull in while I sort of ask myself a question and try to answer it. Maybe you can help me. So there was a good question that the way it kind of was worded was how to deal with duplicate data, basically during import if there was a failure in the middle. And I just wanted to cover this part because certainly in ClickHouse Cloud, we had many users onboard large amounts of data. And so one of the challenges they run into is that when you onboard that much data into any sort of environment where there's network connectivity failures, whatever, right? There's lots of reasons long-running connections could get interrupted. What they saw sometimes is, interruptions in the middle of this import, and then they had to kind of figure out, okay, where did this fail? How do I now sort of truncate some data and start from another point? And so the best practice that we now have solidified with our users, and we're actually publishing a blog very soon on this, and we'll be automating it to some extent, although every use case is hard to automate, is to really break up your import into batches and import it in smaller inserts. We've worked really hard, certainly on our side, to make sure that things don't get interrupted for say up to an hour. But even then for us, on our side, there could be some infrastructure reasons that connections could get interrupted. So, we work really hard to make it possible for long-running connections to run, and some of them can run up to like 24 hours. It's just not recommended, I would say, kind of as a general practice. If you want to avoid these types of interruptions, break it up into smaller insert jobs, import them. Work with us. We have at this point a lot of experience, not only how to safely import, but also how to import things in a fast and cost-effective manner. So you might be able to, basically save some credits by working with us. Definitely reach out to support. Just say, I've got a good amount of data to onboard, help me, right? We will give you the best practices. And again, very soon this will be published in a guide that everybody can access and read through, and hopefully automate it in the future even more. So that's my answer. Anything to add? I know Riyadh, Alexei, Zach, you've all worked to support customers with these larger onboards. Anything that I didn't cover kind of as best practices that you want to mention now? No? Okay. In that case, any additional questions that I didn't ask that you would like to answer? I know we're like way over time, but if there's something else that's on your mind, please raise your hand and jump in. Zach.
Yeah, there was one additional question about monitoring current running queries for a session and kill the queries, for an on-prem implementation. The short answer is there is no way to do it through a UI. But the longer answer is that the UI that we expose in the SQL console to support this functionality is actually just using SQL to query your system.processes table and return results from it in like a kind of more approachable manner. This is already possible just by kind of polling system.processes. You can look at the fields that are present in that table. It's in memory, so the cost of these queries is very low, and you can instrument some sort of polling job that runs whatever frequency you want, that exposes things like query ID and progress and all that kind of stuff, just by kind of polling the system.processes table.
Very cool. Anybody else? If not, Tyler, over to you. I don't know if you want to close with a few remarks about recordings and.
Yeah, indeed, I will. First of all of you who have been here for the last hour and 20 minutes, thank you. We have a lot to share. And to be honest, we only scratched the surface. There's even more that we could share and more that we will share over time coming up. I think the response and the number of questions and the number of attendees indicates that this is a thing we should do more often. And that's exciting to me because the opportunity to talk to you, our users, is what matters to all of us immensely. Tanya said a thing, which is if you're importing a bunch of data, reach out to us. I would also add, if you're interested in ClickHouse, if you're interested in ClickHouse Cloud, if you wonder whether it's a good fit, if you want to engage with the community of others who are using it, reach out to us. The easiest way is clickhouse.com/Slack. You can hop onto our Slack channel. We're always happy, and we take turns as a company hanging out in Slack and answering questions. GitHub, of course, exists, and we keep a close eye on questions as they roll into GitHub as issues or as discussions. Our Twitter is ClickHouseDB. Hit us up on LinkedIn. Join a meetup in your city. You can find them all on meetup.com/pro/ClickHouse. And if you're interested in hosting a meetup in your city, let me know. Thank you. Databases are only as good as the data that is in it. A software product is only as amazing as the users that use it. We'll have a recording of this live for all of you. Thank you so much for joining us, and we look forward to